Hi students, welcome back to my YouTube channel SADHIK Physics. So after long time, so I took 1 month delay to post one more new video, no, right? So again we'll never stop learning the physics now, right? Again welcome. So SADHIK Physics, today we'll discuss one more topic from the ray optics, no, that is about lenses and lens formula, ray diagrams and combination of the lenses and lens and mirrors and some different applications. Okay. So about the lenses, no, we are going to learn thoroughly from this video, right. So let us start our topic, no. First let us go for lens. Okay. So here lens, what is meant by lens now? So we know that we are wearing the goggles, no, therefore this is a lens now, therefore how it will be, it is a transparent one now. So if you really touch these type of lenses, no, so in some type of lenses, no, at the midpoint, so slightly thickness will be there, so at the edges, no, it will be becomes like a thinner. Some lenses are there at the middle point, thin it will be there, at the edges, no, it will be thick. Okay. So therefore it is having some two refracting curved surfaces now, clear. So therefore here we will take it as like a one refracting curved surface now and another one more refracting curved surface, where at the middle point, so therefore thickness is there, and at the edges, no, therefore this is a thinner, so this will call it as like a convex lens, clear. So and one more type of lens is there, no, therefore here this is one more refracting surface, no, another one more refracting surface, so where middle at the middle point thinner is there, at the edges, no, thicker is there, so this is called as like a concave lens. And there is some more lenses are there, like a one side it will be a plane, either curved, right, and another one more curvature, again one more curvature, no, like a plano convex, plano concave, concavo convex, convexo concave. So these type of lenses will be there. How to deal such type of things, no, so we'll learn slowly. So here first basic level, therefore we are going to take these type of lenses now, clear. So now let us see. Here there are some other names also is there. Suppose if any one parallel beam of light rays are coming and falling on this or no, a parallel beam of light rays after, right, so this light rays if it falls, no, it is going to converges to one point. So therefore you might have see some lenses, no, some reading glass, no, you might have played in your childhood, no, you will place in the sunlight, no, therefore the sun, therefore it is going to spot it on the paper will be get burned, no, therefore like that a parallel beam of light rays are coming, therefore it is converges to one point. So this type of lens we will call it as like a converging lens, clear. Suppose if a light rays are coming, if a parallel beam of light rays are coming and falling on this one, no, so therefore here these light rays are going to diverge, right, so these light rays are going to diverge, no, therefore this type of rays are, so this type of lens we call it as like a diverging lens, clear. Converging lens means convex lens, diverging lens means concave lens, no, clear. So now let us see different right positions, no. So you might have see the like a reading glasses, no, you might have placed a convex lens very near to the writings, small writings, no, so that you can able to see maximize on this, clear. So therefore here at different positions of your object, therefore different positions of the image you are going to form now. So let us see the ray diagrams now, right. So what are the ray diagrams now, right. So before going to draw the ray diagrams now, we will see some rules to draw the ray diagrams. So rules, draw ray diagrams, right. So what are the rules now? First let us see, this is your convex lens, no, right. So if any light ray, so which is coming parallel to the principal axis, no, suppose this is your principal axis, right, so straight line passing through the center, no, right. So therefore here it is a, if any light rays which is parallel to the principal axis, after refraction So definitely, so therefore it is going to pass through the principal focus. Clear? So we can call this one now. These light rays are converging to this point of this, we can call it as like a focus, and this distance we will call it as like a focal length. Here these light rays are appears to be coming from here. So therefore this is said to be like a focus, and this is said to be like a focal length. Clear? So therefore here if any light ray which is coming parallel to the principal axis, after refraction definitely it will goes to the principal focus now. Suppose if any light ray, so which is passing through the principal focus, reverse of this one, no? If any light ray which is passing through the principal focus, after refraction it will goes parallel to the principal axis, reverse. Clear? Now again if any light ray which is passed through the center of this one, no? Therefore optic center, so therefore without any refraction, no? Therefore it will be able to pass through it. Clear? So this type of these are the rules, no, we need to follow to draw the ray diagrams. Exactly the similar way, so for concave lens also, therefore here this is a concave lens. So if any light ray which is passing through the if any light ray which is passing through the principal focus, parallel to the principal axis, no, therefore after refraction it appears to be going from the principal focus. Clear? So any light ray, so which is passing through the principal focus, let us see here, no. So if any light ray, so which is passing through the principal focus, right, therefore it is appears to be going from here. So then after refraction it will goes like a parallel to the principal axis, right. So next if any light ray which is passing through the optic center, there is will not go any refraction, no, so it will go as it is. Clear? So these are the rules, no, we have to follow to draw the ray diagrams for our lenses. Clear? Now let us see, therefore here in front of the lens, no, how many positions are we can make it, no, definitely there are 6 positions are there. So we will draw, so one by one, so about this one, no, right. So we will go for one converging lens, no, first, right. So this is one converging lens, no. So where are the objects you can keep it, no, first of all let us see. I will tell you easily to remember this one, no. Suppose how many positions are there? There are totally 6 positions are there. One is what? One is at infinity. So next one is beyond center of curvature. Therefore there are 2 positions are there. One is principal focus, another one is center of curvature, no, C1. Clear? So therefore at infinity 1, so second one beyond C, third one on C, fourth one in between C and F, so fifth one on F, so sixth one in between F and O. Clear? So these are the 6 positions we can keep the objects, no, so that the images can be formed. So how to remember it, no? Very simple one, no. I will tell you, already I told. So in mirrors already I told this one, no. Therefore let us see this one, no, how to remember this one, no. See here, remember this. So if an object is any infinity, so image where it will form? It will be formed at the focus. Now you try to see my fingers also. Suppose if an object is coming from infinity to here, the image slightly it will goes from here to here. So therefore slightly it is becoming larger and larger and larger. So but it will be diminished only. But once it is comes to the center of curvature, image also will comes to the center of curvature. So object size and image size also it will be the both are same. Here magnification will be 1 only. Now if an object goes from C to F, so if it is going from C to F, therefore it will be goes very far away and becoming larger and larger and larger. Once it is comes to the focus, so it is goes to infinity. Then if an object is comes to in between this one, no, therefore image it will be formed in the inside this one, no, like a virtual image. Clear? So right, if you do not understand, just again try to re-listen this one, no, therefore slowly, so that you can understand very clearly and you will never forget any ray diagrams. So first let us see here, no, we already drawn if an object is at infinity. So if an object is at infinity, so where the this is your object is at infinity, Therefore where the image it will be created, no, here the image it will be created. This is your image. How the image is there? Image is like a point size. Clear? So how that image is there now? These really light rays are coming and falling on this one. Suppose if you might have see you might have played with a one converging lens or reading lens, no. Therefore here, so you will see the sunlight, no, the spot which is formed on the paper. that really the spot is formed on the paper now. Therefore, that is really light rays are coming and meeting, that is called real image. Clear? So, therefore, and how the image is there, this is smaller image, that image is what? Image of the sun actually. So, how much size of the sun is there? Very big, but how the spot on the paper on the spot on the paper, no, it will be very smaller, right? So, if possible, no, therefore, I will play a small video here, no, so that you can visualize this. That spot of the sun is there, no, that is nothing but a image. Clear? Really light rays are coming and meeting, so this you can call it as like a real image. Real image. So, which is formed on this one now. How it is there? No, small size, therefore, a diminished image. Diminished. Clear? So, it is a real image and it will be diminished, small size. Where it is formed on the focus. Clear? So, these are the nature of the image where object is kept at infinity. So, for this one, no, if you keep an object at infinity, therefore, where the image is created now, therefore, here infinity light rays are coming parallel, diverging, these light rays are appears to be coming and falling, appears to be coming from here. So, this is light rays are appears to be coming, therefore, really these light rays are not formed at this point, no. So, this is we can call it as like a principal, at this point we can call it as like a principal focus, no. So, therefore, this is not really this image is formed, no, this is called like a virtual image. Understand? So, it is a virtual image. Clear? So, therefore, here where it is formed, no, formed at the focus, no, this is really light rays are not coming from here, but really appears to be coming from here. No. Clear? Now, we will see. So, here we can keep the object at different positions, no. So, now we will keep the object at beyond the C, beyond C. So, we will follow the rules and regulations, no, to draw the ray diagrams, no. So, if an object is at this point, no, therefore, here the light rays are coming parallel to the principal axis. So, after, right, so therefore, after refraction it is goes to the principal focus. Clear? Now, again, so one more light ray, so which is coming and falling on this one now, principal focus. So, therefore, here the image is created now. Clear? How the image it is there now? How the image it is there? So, this is your height of the object and this is your height of the image. Where it is formed now? It is formed between now F and C. But really these light rays are coming? Yes, real light rays are coming and meeting. So, therefore, this is you can call it as like a real image. You understand? Clear? So, real image, how it is there now? It is inverted image, inverted, and how it is there now? This height of the object is there, height of the image is smaller. So, that is said to be like a diminished image, real, inverted and diminished. Clear? So, again if it is comes to here, again this image will comes to here now, again if it is coming here now, it will go beyond onto this and come to the infinity, come to the focus, image will go to the infinity, real, inverted, diminished. Clear? So, now let us draw. So, one more thing, no. Suppose if an object is there, if an object is kept at a center of curvature, no, this is your center of curvature. So, therefore, this is C. So, you know that if a light rays are coming up parallel to the principal axis, after refraction it goes to the principal focus. Clear? So, therefore, one more image is there, one more is there, no. Therefore, if a light rays are coming and falling at this point, no. So, now here where the image is created, no, this is your image. Therefore, this is your center of curvature. No. Clear? So, therefore, this is your image, this is your object, no. So, object distance, image distance same, height of the object, height of the image it will be the same, no. So, how it is there now? Really light rays are coming and meeting, therefore, real, so inverted and diminished, sorry, same size, not diminished, no. So, therefore, it is the same size of object, size of the object, size of the image it will be the same. Clear? Clear? Real, inverted, same size. Just we can make it like a, if you want to have any situation now, inverted image, no, therefore, where object should be fall at the center of curvature. So, same size of the image it will be created with a inverted way. So, this will act like a inverter. Clear? Now, let us see here object is kept in between the Now object is kept in between the center of curvature and this is focus. Clear? So this is your height of the object, no? Right? Height of the object. Therefore light rays are coming parallel to this one, no? So after refraction, no, therefore it will goes to the principal focus. Clear? Now next one. So here if a light rays are coming and falling here, no, therefore here clear. So this it will be the center of curvature, this it will be your image. Clear? How it will be the image is there now? Therefore it is really light rays are coming and meeting, therefore it is real image. How it is there now? Inverted now. How it is looks like now? It is smaller size and this is bigger size. So therefore we can call it as like a magnified or enlarged. Clear? So therefore it is enlarged image. Clear? Right? So now let us see if an object is kept on the focus, no? So if an object is kept on the focus, right? So this is on the focus, no? Therefore here now these light rays are coming and falling parallel to the principal axis, no? Then after refraction, therefore so it will pass through the focus, no? Then afterwards if a light rays are going parallel, so this is going parallelly up to infinity. Clear? So where the image is created, no? The image is at infinity. How it will be there now? Real. If you go to infinity, real, inverted and magnified. Clear? But we cannot go there, no? Therefore here you understand, no? Next, very important, no? Most important diagram, no? So therefore here if an object is kept in between the focus and this is your optic center, this is no. So how will the image will be there now? Therefore if a light rays are coming parallel to the principal axis, then goes to the principal focus, no. Now if a light rays are coming, so therefore these light rays are like diverging here now. Clear? So diverging. So these light rays are appears to be coming from here. If these light rays are coming and meeting at this point, no. So this it will be your final image. So this is your object, this is your image. Clear? So how the image is there? Really these light rays are coming from here? No. Therefore that's why you call it as virtual image. Clear? How it is there now? Therefore here head is on the top, here also head is on the top, therefore no inverted, no. So that type of image you can call it as like a erect image or enlarged, virtual, erect and so magnified. So this is a situation now where this convex lens will act like a magnifier glass, or we can call it as like a reading glass. Or mostly if you go to the watch mechanic, no, so they will use this type of lens, no, then to see the magnified one. Clear? So now these are the ray diagrams, no, but for diverging mirror, diverging lens, no, therefore here if a light rays are coming parallel to the principal axis, no, therefore you will drawn already, no. So if you keep any object, any position, does not matter onto this. So here this light rays it will come and it will get diverged, no. So therefore this light rays appears to be coming from here. And another one more light ray, if you can take it here, no. So therefore here this is your image, it will be there, this is your object. Therefore what you can write it now here? So therefore here it will be like a virtual, erect and diminished. Clear? So these are the ray diagrams, no, for a convex lens and concave lens, no. Right students, we will see one more concept, no, that is lens formula. Clear? Now let us see here, no, lens formula. So here we drawn so many ray diagrams, no. Let us see Here let us see, so this is what you can write it down. This is, you can write it as like a object distance, clear. So this we can call it like a image distance, right. All the distances should be measured from the optic center only, and this is your height of the object, and this is your height of the image, clear. So this is, we can call it as like a focal length of your lens, clear. Now so we want to have the relation between of all these one, so this relation can be given from the lens formula. What is this lens formula? 1 by f is equals to, so 1 by v minus 1 by u, clear. This is a lens formula. Magnification, what is the magnification? Therefore how much amount of magnified image or diminished image. So therefore this is, we can call it as height of the image by height of the object, that it will be equal to v by u. So if you eliminate this is v, so therefore you can write down f by f plus u. Suppose if you eliminate u, so therefore f minus v by f. So these are the magnifications, so of your lens. To use this formula, compulsory you have to follow the sign conventions. Compulsory sign conventions is required. So what is sign conventions now? Clear. So let us see, this is your lens, clear. So this is the lens, so therefore this we can rewrite it as like a optic center, therefore what you have to do, how to follow the sign conventions, so take this optic center at origin. So this side it is positive x axis, this side is negative x axis, positive y axis, negative y axis, clear. So therefore if any object kept toward all the distances should be measured from the optic center only, that is origin, so this side object is if it is any distances are there, this side it is negative, and this side it will be the positive, and this side it will be the positive, and this side it will be the negative. So one more important, if you have to keep always, most of the times you keep the object on the left side, u should be negative. You understand, focal length of this lens, it is formed toward this side. So definitely focal length of your convex lens. So for convex lens is positive, for concave lens is negative, clear. So object distance, most of the cases you can take it here as a negative, and image distance we have to see as per the condition, clear. So here let us test, therefore here, so this is your height of the object, height of the object is positive or negative? Positive. So here object distance is what? Negative, because this distance, what is the image distance? Image distance is negative, height of the image is nothing but a positive, clear. You understand, in this situation, so here object distance is negative, so here image distance is negative, so height of the object is positive, height of the image is negative, clear. Height of the image is negative, height of the object is, height of the image is positive, and height of the object is also positive. Image distance is negative, object distance is negative, focal length of this lens is negative, clear, right. So these are the, right, we need to follow the sign conventions, to use of all these formulas. So one more formula we can write it, therefore, so power of the lens, therefore very important, power of the lens. So power of lens. So here what is the power now? Suppose here there is a lens is there, so this is one lens, right. So here, therefore here if any light rays are coming here, so parallel to this, therefore it is going to converge to this point. Therefore here what happened now, actually this light ray would have gone like this, but this much amount of bending of your light ray is taken place now, or this much amount of is getting deviated now. If it is more deviation is there, so therefore this focal length it will be the less. If least deviation is there, so therefore focal length will be positive. So if you really write it now, therefore tan delta, so you can write down this is your height, so therefore by focal length of this one. Therefore this is to be treated to be like a power of the lens, or this power of the lens is inversely proportional to the focal length. Therefore power it can be written as like a 1 by focal length is in meters. But if it is given in centimeters, no, therefore it will be 100 by focal length if it is measured in terms of like a centimeter. So this is measured in terms of like a diopter, so power of the lens. So this also you have to take into sign conventions, no. So for convex lens, so power is positive, and for concave lens power is negative. You might have seen optical lenses, those are having the glasses, no. So the doctor will prescribe that is a plus some 1.2 like that, no, 0.2 like that, no. Plus means for them they are provided convex lens. So if it is provided like negative, so therefore they are provided like a concave lens, like that you can understand. Clear? So this is for lens, no. For mirror, so for mirror what you can write it now, for mirror, so you can write down 1 by f, it will be your in mirror. So mirror power, no, like again suppose only one curved surface is there. So this is one curved surface, no, who is having refractive index, this is n1 and this is n2. So therefore here n1 and n2, therefore here the power can be written as power of the sun now, therefore n2 minus n1 by radius of curvature of the sun. So n2 is what, where after refraction entering into the one medium. So n1 is what, before refraction, therefore the lighter which is there in the medium. R is the radius of curvature, also follow the sign conventions compulsory for all this one. Clear? So these are the powers, right? So power of the lenses, power of the mirror, power of your curved surface also we discussed. So we will see today the questions, no, mostly all possible different type of questions, no, we will see it now. Clear? Okay, let us see, first of all let us go for basic level questions, no, then we will go for slightly difficult level. Clear? Now, so if you are not able to see the question properly, but listen, so try to follow my words, no, then you can understand. Find out the position of the image. Therefore, so here focal length convex lens is given, object distance, no, therefore here you can write it as object distance is minus 30 centimeter, no. So focal length is given as plus 20 centimeter, no. Clear? So therefore 1 by f is equals to 1 by v minus 1 by u. So 1 by 20, so therefore 1 by v we want to calculate it, no. So minus 1 by minus 30, so therefore minus of minus plus taken toward this side, now 1 by v, 1 by 20 minus 1 by 30. Clear? Clear? So this is minus of minus plus, but if you take it here now, therefore it will be the minus. So we can make it like a 63 and 2 I can multiply 3 minus 2, that is 1 by 60. So I can multiply with 3, can multiply with 2. So therefore v is equals to therefore 60 centimeter plus. Plus means somewhere here, therefore here 60 centimeter, therefore the image is created. Clear? So like this follow the sign conventions only is very important now. Clear? So one more question. So let us see this question. So here okay, here object distance is what, it is minus 30 centimeter, no. So focal length it will be equal to minus 20 centimeter. Why? Because it is a concave lens. So 1 by f is equals to 1 by v minus 1 by u. So 1 by therefore minus 20 is equals to 1 by v. So minus of minus plus 1 by 30. So taken here now 1 by v. So minus 1 by 30 minus 1 by 20. So I can multiply 2 and 3 60, therefore 2 and 3, therefore minus 5 by 60. So therefore v is equals to minus 60 by 5. 5 ones are 5 12s are, v is equals to minus 12 centimeter. Clear? Minus 12 centimeter, no. Therefore here somewhere here, no, therefore minus 12 centimeter, no. So here the image is created, no. Clear? So this is the point size only, therefore magnification. So, you might have not needed. Clear? Right. So, let us go for another question now. Right. So, therefore, here there is a slightly different things are there, no? Slightly important question, no? A beam of light converges at a point P. A lens is kept in the path of the converging beam here, no? So, 12 centimeter from point P. At what point does the beam converges if the lens is convex lens and concave lens, right? So, let us see here now what is given now. A beam of light converges to point P. That means there is a one beam is there, no, where it is converging, no, where it is converging here, no, here, converging at point P. Clear? So, at this point, no, in this point, in its path of convergent beam 12 centimeter from point P. Therefore, at 12 centimeter from point P, therefore, this is 12 centimeter from point P. So, therefore, converging lens is there, convex lens is there, no, this is here one convex lens. Focal length is how much, no, therefore, 20 centimeter, no. So, 12 centimeter it is kept now. Therefore, so convex lens, first let us do convex lens, no, then we will see therefore concave lens. So, these light rays are converging to this point now, therefore, what will happen now, already convergent beam is there. So, therefore, this is also going to converge more here, no, therefore, what is going to happen now, this is going to converge to this point here. Clear? So, this point, this is nothing but like a image. Clear? You understand now? So, these are going to converge to this point. Clear? So, now what happens now, here it is going to converge it, no, therefore, here let us calculate this distance, no, but here object distance where it is there, no, there is no this side, no, this side it will be our object distance, u is equals to plus 12 centimeter. This is what you need to follow the sign conventions. Focal length is equals to how much now, 20 centimeter, no. So, you can write it as 1 by f is equals to 1 by v minus 1 by u. So, 1 by f it is how much now, 1 by 20 is equals to 1 by v. So, minus therefore, it will be 1 by 12. Taken toward this side, 1 by v is equals to 1 by 20 plus 1 by 12. So, therefore, here we can make it like a 60. So, therefore, here this is 3 into 3. So, this is your 5 into 5. Clear? So, 1 by v, 5 plus 3, 8 by 60. So, v is equals to 60 by 8. How much it will be now? 2 4s, 30s, 2s, 15s, therefore, 2 1s, 2 7.5. So, they are going to form at 7.5 centimeter. This distance is 7.5 centimeter. Clear? Right? So, that is why always right. So, object distance cannot be positive, cannot be negative. Clear? So, it can be positive also. Now, what is given now? One more question now, not only this one question, one more question is there. There is a concave lens of focal length 16 centimeters is kept here now. So, now let us see here now. So, in this path, suppose here this is your convergent beam now. So, this is your point P. Clear? Now, therefore, in this path, no, therefore, what you are going to do now, therefore, here there is a concave lens is kept. Where it is kept now? Again 12 centimeter it is kept here now. Clear? Now, this is your diverging lens, no, therefore, it is not allowed to converge it, no, therefore, it will be maybe, so this final image will be formed at this point, no, maybe somewhere here. Why? So, it will least converges now. This is your final image will be there. Clear? You understand, no? So, let us find it, no, this value. So, also u is equals to plus 12 centimeter. Focal length is given as 16 centimeter, no. So, focal length is given as minus 16 centimeter. Clear? So, 1 by f, 1 by 16 minus, so you can use that formula 1 by v minus 1 by 12. Clear? So, taken toward this side now, therefore, 1 by v is equals to, so 1 by 12 minus 1 by 16. So, what you can write it now here? So here 12 and 16 I can take it as like a 4 common, no, 4 3s are 4 4s are, right, 16 into 3. So therefore here into 3 into 3, so into 4 into 4 into 4. So how much will get it now? 4 by 48 minus 3 by 48. Clear? 1 by 48. Therefore V is equals to plus 48 centimeter. Where the image is created now? Therefore now 48 centimeter it is created at this point. Clear? So try to understand this situation. No? So these type of concepts compulsory. So in combination of the lenses, no, we require. I think you understood very clearly. So therefore how to apply these lenses, lens formula. Clear? Now let us see this question. No? So slightly one learning is there in this from this question. No? Right. A lens has a focal length is f and aperture of the diameter is d, forms an intensity of the image is I. So suppose there is a lens is there, this is one lens, okay. So lens is having lens, it is not like this always, no, there will be like a circular it will be there. So this diameter it is given as d, so it is having the focal length is f, clear, and the image intensity of the image formed to this one, no? That means more light rays are coming and falling, so definitely they are going to converge to this point now. Therefore, right. So therefore here there is a intensity is I, clear. So you try to understand, if more light rays are coming, more intensity it will be there. If less number of light rays are passing through this one now, therefore intensity it will be get decreased. So now what happens now? Therefore here it is a diameter. What will be the intensity? Intensity is directly proportional to this area of this one now. Therefore this is area. So intensity is directly proportional to or some constant, no? So you can write it as some constant. So it is constant into pi. So d square, diameter is there, no, pi r square means d by 2 whole square. So constant into pi into d square by 4, clear. So this is the intensity of the image because light rays are passing through complete portion of this one. But here the aperture of the diameter d by 2 in the central region of the lens, no, covered by the black paper. That means, so at this point, no, therefore some central part of this one, no, certain amount of this was covered by light, I mean covered by black paper. So means what? Therefore here this is your some covered by this one now, clear. So now here this means, now through this one now light rays will not pass through it now, clear. So therefore through this one now light rays will not pass, through which region now light rays will pass now? Through this region, the light rays it will be able to pass through it. So therefore here intensity will decrease, but the focal length, see here, if the central region is there, no, therefore it is covered, but here light rays are coming and definitely it is going to bend toward this side, no. Therefore this portion of the lens, no, it will work as it is onto this, does not depend upon this portion of this one, no. Therefore focal length will not change, focal length do not change, clear. What is going to change now? So the only this portion of the light will pass through it, no, this portion of the light it will be able to pass through it, this portion of the light will not pass through it, no. So less amount of light it will be reaching to this point, no, intensity will be decreased. So focal length what will happen, no, will not change, but intensity what is going to happen, no, is going to decrease. How much intensity it will be there now? I dash it will be equal to how much amount of area of the light, no, passing through it, no. This is your area, initial area, suppose constant pi d square by 4 minus this much part. How much now? This diameter now, this diameter is d by 2 is a diameter which is covered onto this. So this is your full area of this one now. In this much part we are going to remove it, k into pi into, so therefore d by 2, therefore pi therefore this pi d square by 4, no, pi by 4 into or pi by 4 into d by 2 whole square, clear. So therefore here k into pi d square by 4, you can write down 1 minus 1 by 4. So therefore here 3 by 4 k into pi d square by 4. Therefore intensity, so therefore I dash it will be equal to k into this one is nothing but this one, no, 3 by 4 I. Therefore the intensity of the image, no, therefore it will be like a 3 by 4 I. So what should be the option, no? So this should be your option. But learning thing is this only, most important learning, no. So if you cover the black paper or cover the lens, no, some part of this, so the focal length will not change, no, only the intensity of the part is going to change. So this is one important concept, no, you need to learn, clear. Now let us go for one more question, no, clear. So here magnification it is given, no. So find out the position, nature and size. So here therefore you know it already. So lens formula we have to use it, no. This is here some simple line object only. Therefore here, so u is equals to minus 30 centimeter. Focal length is nothing but plus 20 centimeter. So 1 by f is equals to 1 by v minus 1 by u. So 1 by 20 it will be equal to 1 by v minus of minus 1 by 30. So 1 by v is equals to 1 by 20 minus 1 by 30. So therefore what will happen now here, this is 3, 2, therefore 1 by 60. So image where it is formed, no, plus 60 centimeter. So these are the image position. Plus means this side it is going to form here, no. Definitely, obviously, so therefore where the image is there, no, actually here this is your 20. So definitely this is your 40. So in between C and F it is there, no, definitely how the image it will be there, image it will be so more magnified, so real, inverted, clear. Now we want to calculate the size of the image also. Therefore magnification, we can write down height of the image by height of the object, it will be equal to v. V is how much, no? So it is 60 divided by u. U is how much, no? Minus 30. So height of the object is how much, no? Height of the image is equals to, so therefore minus 2 into 3. So therefore height of the image is equals to minus 6 centimeters. So minus indicate that therefore it is a inverted image. Understood? Minus downward, clear? So therefore somewhere the image, no, so it is going to form now. Therefore this is your 6 centimeter, no. So this distance is nothing but a 60 centimeter, clear? So how it will be there, no? Therefore it is like a real inverted magnified, clear? Now we will go for another question. Let us see this question. Here therefore here concave lens is given, no? Therefore u is equals to minus 30 centimeter. So focal length it is given as minus 30 centimeter, no? So 1 by f is equals to 1 by v minus 1 by u. So 1 by f is nothing but a minus 1 by 30, it will be equal to 1 by v minus or minus plus 1 by 30, clear? Taken here, no, 1 by v is equals to minus 1 by 30 minus 1 by 30 minus 2 by 30. So v is equals to minus 15 centimeter. So therefore v, what we got it now, minus 15 centimeter. Now this is your image distance, clear? So that means somewhere it will be created here now. This is your 15 centimeter, clear? Now what will be the magnification now? Therefore height of the image by height of the object, therefore v by u. Height of the image we want to calculate. Height of the object is nothing but 3 centimeter. So image distance is nothing but minus 15. Object distance is nothing but minus 30. So therefore it will be 1 by 2. So height of the image is nothing but 3 by 2. So therefore 1.5 centimeter. This is plus means, so therefore above the principal axis now. Clear? So therefore above the principal axis now, right, here it will be created. Clear? So how the image it will be there no? So for mostly this concave lens no, so therefore it will be the virtual image, erect and diminished. Clear? So for concave lens no, therefore this is only the nature of the image. This is your height of the image. Clear? Understood no? Now let us see one more question now. Clear? Right. A needle is placed 45 centimeter from the lens now, 45 centimeter from the lens. So from the lens forms an image on the screen placed at 90 centimeter away on the other side of the lens. Okay. Identify the type of the lens, determine the focal length, what is the size of the image, and if the size of the needle is 5 centimeter. Clear? Therefore here what is given now? Therefore here there is a lens is there no, we don't know what is that lens no. So here height of the lens is about height of the lens is nothing but 5 centimeter. Clear? So where it is kept now? From the lens no, therefore here 45 centimeter from here no. Clear? So away from the lens and the image on the screen placed at 90 centimeter, therefore this side it will be the 90 centimeter. So therefore it is going to placed on this one. This side it will be the image is created on the other side of the lens. Identify. So definitely usually this side the image is created means compulsory this should be convex lens. Clear? So this is your convex lens, therefore we want to calculate the focal length of this one now, right? So focal length and what is the size of the image, height of the image we want to calculate it now, focal length now we want to calculate it. Clear? So use the formula 1 by f is equals to 1 by v minus 1 by u. We don't know 1 by f is equals to object distance is minus. So therefore here image distance is positive. So v is equals to plus, here u is equals to minus. So plus is nothing but 90 centimeter. This minus of minus plus 1 by 45. So therefore 2 by 2. Therefore here 1 by f is equals to, so 3 by 90. Therefore f is equals to 90 by 3. So 30 centimeter plus. Plus is there means, so here plus 30 centimeter plus means convex lens obviously. Clear? Image distance now. Therefore you can calculate magnification now, height of the image by height of the object, it is v by u. Height of the image we want to calculate, height of the object is 5. So v is equals to 90 plus 90 but minus 45. Minus 45 means 2, height of the image is nothing but a minus 10 centimeter. Therefore this it will be your image. Minus 10 centimeter. Clear? So convex lens. So this all are this. Clear? Understood? Right. Here no. Therefore let us see here one more question. No? An object is placed at a distance of 1.5 meters. Okay, 1.5 meters no, from a screen, and a convex lens is placed in between produces an image is magnified 4 times on the screen. What is the focal length and position of the lenses? Position of the lens. Okay. So here object is placed 1.5 meters from the screen. Therefore here this is your the screen is there no, this is your object. What is the distance now? Therefore 1.5 centimeter means, so 1.5 meters means 150 centimeter now. This distance is, so 150 centimeter. clear? So a convex lens is placed to produce the images, therefore here there is a one convex lens is placed here somewhere now. Okay. So therefore what will happen now, image magnified 4 times on the screen, therefore here height of the object no, therefore here on the screen no, therefore here it should be the height of the image, it will be equal to, so 4 times of your height of your object. Produces the image magnified 4 times on the screen. What is the focal length? Therefore we don't know, actually we want to calculate it no, therefore here suppose this is your u distance no, this is your compulsory, what you want to calculate now, position of the lens. Okay, first focal length you have to calculate it no, focal length, so v that is nothing but a 150 minus u, clear? So we can have two equations here no, therefore here magnification is given height of the image by, so height of the object, this it will get it as like a minus 4. Why minus 4? Definitely it is inverted, formed on the screen means compulsory it is like a real image. So real image means minus 4, therefore here, so v by u, so that implies minus 4. So image distance it is nothing but a 150 minus u by, therefore it will be minus u, clear? So therefore taken here no, therefore 4u is equals to 150 minus u, that implies 5u is equals to 150, u is equals to, so 150 divided by 5, therefore it will be 30. So u is equals to 30 centimeter. So u should be equal to 30 centimeter no, so v should be equal to therefore 120 centimeter, clear? Therefore now what we want to calculate now, focal length of this, how to calculate the focal length now, so 1 by f is equals to 1 by v, 1 by 120 minus of minus plus 1 by 30, clear? So 1 by f is equals to, I can multiply with 4 into 4, so 5 by 120, so focal length it will be equal to 120 divided by 5, so 5 how much no, 5 to 4, therefore 24 centimeter focal length, right? So position of the lens no, so we got it as 30 centimeter from the object or 120 centimeter from the screen, clear? Focal length is about 24 centimeter. Understand the question, so therefore you can solve very easily, right? Now let us see here now one more question. Right. Now an object is placed in front of a convex lens of focal length 10 centimeter. Find out the position of the object such that we get the 3 times of your magnified image. 3 times of the magnified image means, so actually here we can add one more question here no, therefore here find out the positions, we can rate it, positions, 2 positions we can get it. So therefore we can do it for first position no. So what is given now, find out the positions of the object such that we get 3 times of the magnified image, right? Focal length is given how much now, focal length is nothing but 10 centimeter, convex lens plus, clear? Now we can get it as magnification no, one is why I talk about positions no, because one is we can form like a real image and another one is virtual image now, clear? So therefore we will go for first of all real image, so magnification will be equal to minus 3. So second position, this is for what, a real image which is can be formed on the screen. So second one now, therefore focal length is nothing but a plus 10 centimeter no, so magnification will be equal to plus 3 centimeter. So where object and image will be also in the same side, that is this is for virtual image, this is for virtual, this is for real, Understood? Clear? Now we will go for magnification is 3. Now here magnification we can write down, therefore height of the image, therefore here it will be V by U, right. So V is equals to minus 3U, clear. So U should be always negative. So therefore U is negative means what you will get it now, V is equals to, so minus of minus plus 3U, clear. So this is with your, okay, with sign conventions, clear. Right. So now let us see. Now 1 by F is equals to 1 by V minus 1 by U, clear. So 1 by 10. So image, where it is a image is there, no. If it is minus image is there means is for virtual. So this is for real. U should be like a negative onto this. So therefore U should be the positive. Therefore this is V. So 1 by 3U. So therefore here minus of minus plus 1 by U. So therefore here 1 by 10. So I can multiply with 3. Therefore 4 by 3U. So that implies 10 is equals to 3U by 4. U is equals to 10 into 4 divided by 3. So U is equals to plus 40 by 3 centimeter. This is one position, no. Therefore, I mean plus means 40 by 3. So therefore U is equals to more than 10. That means this is formed at a beyond focus, clear, right. So we already included the sign conventions here, clear. So now therefore here what you can write it now, therefore magnification. So therefore here V is equals to, therefore here you can write down minus 3U. So why? This minus indicate that it is on the same side of this, clear. So this is for virtual image now. Therefore 1 by F is equals to, so 1 by V minus 1 by U. So 1 by 10 it will be equal to minus 1 by 3U. So minus or plus 1 by U, clear. So how much it will be now? This I can write down 3 into 3. So 3 minus 1, therefore 2 by 3U. So that implies, therefore 3U by 2 is equals to 10, U is equals to 20 by 3. So 20 by 3 means nearly 6 points something now. Plus means we already included the right sign conventions, no. So this is 20 by 3 from the lens, no, toward the left side, 40 by 3. So these are the positions of your objects such that you will get the 3 times of your image. Understood? Clear? So like this you should think, no. Then we will go for next question. Right. An object of 25 centimeter high is placed in front of a convex lens of focal length 30 centimeter. If the height of the image is formed is 50 centimeter, find the distance between the object and the image. Okay. So what is given now? Object of 25 centimeters high is placed. Okay. So focal length is given. How much now? 30 centimeter now. So height of the object is given 25 centimeter. Okay. Here also you can get the 2 questions, no, right. So one is distance between, right. Here also two questions you can get it, no. So height of the object, no, therefore height of the image he did not mention. So which is can be formed on the screen. If it is mentioned on the form of the screen, no, so therefore we would have get it as a real image, no, but he did not mention anything, no, therefore we can do it for 2 things. So therefore what are the 2 things, no, let us see. So first position, no, height of the image is about 50 centimeter, therefore here it is plus, here also plus, clear. that means magnification is 2 here, no, magnification is 2, this is plus 2 is for what, a virtual image, virtual. Therefore here what you can write it now, v by u, so v is equals to 2u, right. So therefore here we can write down, therefore 1 by f is equals to 1 by v minus 1 by u. So here I can rewrite it as, for virtual, no, 1 by f is how much, no, 1 by 30. So image distance is negative, therefore it will be the minus, so 1 by 2u minus object distance also minus of minus plus 1 by u. Clear? So therefore here I can multiply with 2, I can divide with 2, therefore 1 by 30 it will be equal to 2 minus 1, therefore 1 by 2u. So u is equals to, therefore 30 by 2, therefore it is nothing but a 15 centimeter. So therefore, so v is equals to how much, no, 30 centimeter. Clear? So what will be the, for a virtual distance, no, object distance from object and in this one, no. Therefore how the image it will be there, no, you know already we drawn so many times, no. So we drawn the ray diagram here, no, here like this. Clear? So therefore this distance is nothing but 15, this distance is nothing but 30, and the distance between them it will become like a 15 centimeter. No? Clear? Clear? So therefore here, now therefore the distance between the object and image, therefore d it will be equal to 15 centimeter. Clear? So this distance, no, you cannot calculate, you cannot use the sign conventions to calculate the distance between them. So now next one, it is we can do it for second position, no, second situation, no. So for real image. So what will be the real image now? Magnification will be the negative minus 2. So therefore v by u. So therefore v is equals to minus 2u. U will be therefore here. So therefore you can take it as plus, because sorry here no. Therefore you can take it as negative 2u. So because negative side. So therefore u will be this one, no. Therefore it will become like a positive. So 1 by f is equals to 1 by v minus 1 by u, that implies 1 by 30, 1 by 30. So 1 by 2u minus of minus plus 1 by u. Therefore I can multiply 2, I can multiply 2. So 1 by 30 it will be equal to, therefore 3 by 2u. That implies 2u is equals to 90. So that implies u is equals to 45 centimeter. So that means here this side is your object, no, therefore it will be 45 centimeter. So where the image it will be created, no. So double time of this one, no, therefore here 2u, therefore it will be 90 centimeter. So they are asking distance between the object and the image. So therefore 90 plus 45, so d can be written as 135 centimeter. Clear? So in this way, here learning thing is what, if you want to calculate the distance between the object and image like that, no, please don't use any sign conventions. So I think you understood that, therefore how much is the importance of understanding the formation of image due to the lenses now. Clear? Right? So in this way we can have the two questions in this. Clear? This is one question, this is another question. This is for virtual, this is for real. Clear? Suppose in the question if they mention that it is a real or a screen is placed like that, no, therefore we have to go for so only real. Clear? Because real image can be formed only on the screens. Clear? Right. So be cautious, no. Now we can go for a combination of the lenses, no. Suppose 2 or 3 lenses are there. So I'll tell you one small trick onto this one. No? Therefore, these 2 lenses are separately kept it. No. So whenever there is a combination of the lenses, 1 lens, 2 lens, 3 lens, 10 lens, any lens is there, doesn't matter onto this one. No. So try to follow this trick. No, that is, you do the questions with this lens separately, then take that image will act like an object to this one. No, and then apply the again lens formula. So how many lenses are there? That many lens formula we have to apply, so that you can solve the questions very easily. Clear? So don't follow any tricks or anything. No. So therefore, first of all you apply the lens formula to this, you will get an image, that image will act like an object to this one. No, again apply the lens formula, again one more lens is there, again do the same, again one more lens is there, again do that, like that. Clear? So how many therefore lenses are there, that many number of times, no, you need to apply the lens formula, so that you can solve the problems very easily. And one more formula we can use it here. No, if they are asking magnification, like number of lenses are there, magnification can be written as magnification due to one lens into magnification due to second lens into magnification due to third lens, like that. Any number of lenses are there, that many times you need to multiply the magnification. Clear? Understood? So there is no secret formula for this, so therefore no need to do this, therefore this formula you can use it. Clear? Now, so now let us do the question. No? Find out the height of the final image. So don't bother, first of all remove this one. No? First focus on this. First I will focus on this one. So therefore first lens. No? Therefore what you can write it now, focal length is given as 20 centimeter convex. No? So focal length is nothing but plus 20 centimeter. Clear? Object distance u is equals to how much now? Minus 30 centimeter. So height of the object is given as 4 centimeter. No? Therefore this is plus. So first let us calculate the image distance. No? Therefore here you can apply the lens formula, 1 by f is equals to 1 by v minus 1 by u. So 1 by 20 so is equals to, so 1 by v we don't know, therefore minus of minus plus 1 by 30. 1 by v is equals to 1 by 20 minus 1 by 30. So I can multiply with 3, I can multiply with 2, 60 it will happen now. So 1 by v is equals to 3 minus 1, 1 by 60. So that implies v is equals to 60 centimeter plus. Okay. So therefore what is going to happen now? Therefore here 60 centimeter, somewhere here no 60 centimeter. So here the light rays are coming and falling here now. So this is your image no for this. So this is at a distance of 60 centimeter now. Clear? Now, okay, now we got it till now. So we will calculate the later on to this one, no, height of the final image of this. Clear? So now what we can write it now, here this is 60 centimeter, this is a real object. No, therefore so this object will act like a this image will act like a object to this. So what you can write it now, here this distance is 90 centimeter, in that 60 is gone, therefore this side it will be 30 centimeter. Clear? 30 centimeter now. Now we can so rewrite it now, therefore for this second one now. So focal length is given as how much now? Minus 10 centimeter concave. Object distance is nothing but a minus 30 centimeter. Minus 30 centimeter no. Therefore image distance we want to calculate, final image distance. Again apply the formula, 1 by v minus 1 by u, 1 by so 10 minus therefore 1 by v, so minus of minus plus 1 by 30. Clear? So how much now? 1 by v is equals to, so therefore minus 1 by 10 minus 1 by 30, 3 by 30. So 1 by v is equals to minus 4 by 30. So v is equals to 30 by 4. 30 by 4 means 15 means 7.5 centimeter minus. So minus is there no, that means here where the image is created means, see here, this it will go like this. Clear? So this it will go like this, therefore these light rays are appears to be coming. So this is your final image. Understood? Clear? So this is your final image now. Clear? So now final image is very smaller here. No? Now we want to calculate height of this image. Clear? So for this one you can use this formula. Sir, I don't want to use this formula, I don't know this one now. Means what you have to do? So separately first calculate this height, and from here to here this height you calculate, that's all, you can get your answer now. So better try to practice use of that formula also, right? Now let us see this formula. Now, so only two lenses are there, so we can go for this. Right, we can use this the formula, or we can derive it every time. You can use it for magnification, find the height of the middle image, no, then afterwards height of the final image also you can do it, right. So therefore here let us see. So first let us calculate this one, no. Also you can use this formula, we can use that formula first of all, then afterwards if you want, no, we will derive it now. Clear? So first final magnification, no, therefore this is your height of the image, final height of the image. So by height of the object is how much, no, above 4 centimeter, no. Clear? So therefore first magnification, no, magnification is nothing but a v by u, v by u, v is how much, no, v is 60 centimeter, 60 divided by this side is minus 30, clear, into magnification of due to second one now, therefore minus v by u, minus v, v is how much now, minus 7.5, so by minus 30 centimeter, clear. So therefore here what you can write it now, this is minus minus cancel here now, therefore 31s are 32s are, so 7, therefore this you can write it as 15, so 15 divided by 30 minus means 1 by 2, so therefore height of the final image is nothing but a minus 4 by 2 minus 2 centimeter. So therefore this height of the image is minus 2 centimeter now. Clear? Why minus? Because finally it is inverted image. So I used this formula, so therefore I got it minus 2 centimeter now. So you also do it separately. First find the height of this sun now, then afterwards find the height of this sun now by using the magnification formula, and please comment in the box. Clear? So better to follow this one now for any combination of the lenses. Understood? Now let us see one more question now. Now let us see here now. Therefore here a convex lens A of focal length is 30 centimeter, convex lens of B focal length is 20 centimeter are kept along the same axis with a distance between them is D. If a parallel beam of light is falling on A and leaves B as a parallel beam, then find the distance. This is a simple one now. See, this is one lens is there now, we don't know what, right, this is here A. So focal length of A is how much now, 30 centimeter now. Another lens is there now, therefore focal length of this B, so therefore here it will be focal length is 20 centimeter now. Clear? So what happened now, they are placed on the same axis now. Therefore what is telling, therefore if a parallel beam of light rays are entering, so then definitely it is going to meet at this point. Clear? So where is going to meet at now? Definitely they are going to meet at 30 centimeter now. Clear? So therefore after that also it is going parallel beam onto this one, no? Therefore it will go out parallel beam means compulsory object should be kept at the focus onto this. Clear? So this distance should be compulsory 20 centimeter now. So the distance between A and B is nothing but a D. So D is equals to F1 FA plus FB. So that is nothing but a 30 plus 20, that is nothing but a 50 centimeter. Clear? Is a simple question, no? So you can understand clearly. Right. Now let us go for next question, no? Yeah. Here 3 lenses are given, 3 lenses. Right. So let us solve. Don't panic or don't get confused, no? How many lenses are there doesn't matter, no? So see one lens, one lens, one lens, like that many times you can apply the formula, that's all. So I am not observing this one, no, I am observing this first. So he is asking find out the position of the image found by the lens of the combination. Okay, we have to calculate the final position now. So they may options they may give from this lens or from this lens, from this lens or from the object. You need to calculate it now, because position means compulsory you have to start from one point. Clear? So first let us calculate from here, no. Therefore first lens. So convex lens. So focal length is how much, no? First lens, no. Right? So focal length is how much, no? Plus 10 centimeter, no. U is equals to minus 30 centimeter, no. Right? So where the image will be created, no. Therefore 1 by F is equals to 1 by V minus 1 by U, 1 by 10. So therefore 1 by V. So we want to calculate minus of minus plus 1 by 30. Clear? So 1 by V is equals to 1 by 10 minus 1 by 30 minus 1 by 30. I can multiply 3. So therefore 1 by V is equals to 2 by 30. So V is equals to 15 centimeter plus. Plus means this side. So where the image will be created now? Therefore first let us see this one now. These letters are coming. Clear? So therefore where the image is created now? 15 centimeter. 15, 10 and 15. Therefore somewhere it will be created here. This 15 centimeter it is created now. Right. Now sir, how to this side object is there, no? So in this already I discussed one question, no? Therefore we can apply. So now we will go for this distance is 15 centimeter, no? Now for this one now, object is where it is there, no? Here is object is there. That is converging beam is meeting at this point now. So what is the object distance from the second lens now? From the second lens now, object distance is nothing but this is totally 15, but from here to here this 5 is gone. This is now it is 15 minus 5, therefore 10 centimeter. Here it will take it as plus. I already, if you are seeing this video in this part, no, I already discussed one converging beam concept question, no. So therefore here I will show you. Okay. So converging beam question I already discussed here. So here converging beam is meeting, here converging beam is meeting, no. Therefore we used U is plus. Clear? So same concept, no, same way. So that's why I selected this question here, no. Now therefore here, now U is plus not minus, because this side converging beam is there. What is the focal length of this one now? Focal length is nothing but minus 10 centimeter. So 1 by 10 minus, therefore 1 by V. So minus 1 by 10, no? Therefore 1 by V is equals to, so what you will get it now? 1 by 10 minus plus 1 by 10, no? Therefore 0 by 10. So V will be at infinity. That means, so therefore here this parallel beam of this beam, no? Now what will happen now? It is going to convert into like a parallel beam, because it is going to form like this one. So sometimes they may ask you what will be the distance between them. Therefore it does not depend upon this 10 centimeter, because it's a parallel beam of light rays are coming, because image is at infinity. Either 10 centimeter is there, 20 centimeter is there, 15 centimeter is there, doesn't matter, because parallel beam will go and fall onto this one. So therefore this doesn't not require any distance now. If a parallel beam is coming and falling here now, where the obviously the image will be formed now, image will be formed at the focus. No need to apply any concept now. So if you are thorough, this distance is how much now? This distance is nothing but a 30 centimeter. Clear? So therefore here the image is created now. Therefore from this last lens, so therefore image is formed at 30 centimeter. From the third lens now, so therefore image will be formed at 30 centimeter. Clear? How it will be the image is there? It is a real image it will be there. Clear? So understood, no? So therefore, so don't panic of any questions by combination 2, 3, 4 like that, no, doesn't matter, no, right? So just simply separately try to apply the concepts. Clear? Now let us go for one more question now. Now we have to calculate the velocity of the image. Here lens is also moving, object is also moving now. Clear? So this type of concept I already did in the mirrors also. So same type of concepts now we are going to apply here now. So first let us see here how the object is moving. Object is moving along the principal axis. Therefore, here we will derive one formula here. No? Therefore, if an object is moving along the principal axis, so definitely if it is moving along this, no, definitely the size of the image, no, it is going to change. Clear? Now, let us see here. No? So, 1 by f, it will be equal to 1 by v minus 1 by u. I can rewrite down now f minus 1. So, v minus 1 minus u minus 1. I will differentiate it now with respect to the time. So, this focal length of this lens, no, with respect to the time is not going to change. No? So, this is constant, it will be the 0. So, minus 1 by, therefore, v square into dv by dt. Clear? So, this minus of minus plus 1 by u square into du by dt. Clear? So, this I am taking here, no. dv by dt is nothing but a velocity of the image, no. So, this is here velocity of the image with respect to the lens, no. So, it will be equal to v square by u square. See, if I am taking here, no, after they can take in, no. So, therefore, here velocity of the object with respect to the image. Clear? So, this is v by u whole square I can write down, no. Therefore, we can rewrite it as velocity of the image with respect to the lens, no. With respect to the lens can be written as magnification square into velocity of the object with respect to the lens. Clear? Still more clear way we can write it now. So, that means velocity of the image minus velocity of the lens is equals to m square and velocity of the object minus velocity of the lens. Clear? So, this is here velocity of the image with respect to the ground and velocity of the lens is equals to, so here velocity of the object with respect to the ground minus velocity of the lens with respect to the ground. We can apply this one now. So, here we can rewrite it as, so this is your velocity of the object, it is given now. So, also we have to apply in which direction they are going now. I am considering this is my direction, this side plus x axis, no, plus I cap. Clear? Now, therefore, here velocity of the object is then, no. So, velocity of the object is nothing but a 4 centimeter 4 I cap minus velocity of the lens is nothing but a 2 I cap is equals to magnification is given, object distance is given, no. What is the magnification formula? We written, no, f by f plus u. So, f is how much now? 10 by 10 minus, therefore, it will be the 15. How much it will be now? So, therefore, here it will be the minus 2. So, minus 5, therefore, minus 2. So, minus 2 whole square into velocity of the, velocity of the, this image we want to calculate it now. Clear? So, this is your velocity of the image we want to calculate it. So, velocity of the object is nothing but a 4 I cap minus, therefore, 2 I cap. Clear? So, velocity of the image minus 2 I cap, this is nothing but a 4, therefore, it is into 2, therefore, 4 in, therefore, 4 into 2, therefore, 8 I cap. Taken here, no, velocity of the image, so therefore, it will be equal to 10 I cap. Velocity of the image will be about 10 I cap, will be your velocity of the image. Clear? Right? Here 4 I cap, that is in centimeters per second. Clear? So, now we will go for another question. No? Yeah. Here, how the image is there now? How the object it is moving? Object is moving perpendicular to the principal axis now. Therefore, if an object moves perpendicular to principal axis, clear? So, if an object moves perpendicular to the principal axis, no, therefore, what you can get it now? Here, there is no change, because here it is there, means definitely image will go in this direction now, right? It's 15 centimeter where it will be there. We'll see. Here there is nothing, it is going to change here now. There is no object distance, image distance is not changing here, no, object distance is same every time, no. So object distance is same, so therefore we can rewrite it as like a here height of the image by height of the object is nothing but a magnification. Here height of the image is nothing but m into, so this is your height of the object. So di by dhi by dt is equals to m into dho by dt. So therefore here velocity of the image, so with respect to the lens, no, minus it will be equal to m into velocity of the object with respect to the lens. Here lens is not moving, no, clear. So therefore here now we can apply, here we can calculate, here magnification is not square, but if the object is going here, no, magnification square will be there, but if here object, magnification will not change now. So we can calculate the magnification now. What is the magnification now? F by f plus u. F is how much now? 10 by 10 minus 15. So minus 2 will be your magnification. So velocity of the image minus velocity of the lens is equals to magnification into velocity of the object minus velocity of the lens. So velocity of the image we want to calculate it now, image minus lens is not moving now, therefore 0. So m is nothing but a minus 2. So object is moving along the y axis, no. So therefore 4 j cap minus 0, clear. So velocity of the image, it will be equal to minus 8. So j cap, no, centimeters per second now. So minus j cap means what will happen now? Therefore definitely the image will go in the downward direction now. With a speed it will be equal to 8 centimeters per second now in a downward direction, clear. So in this way you can solve, right. Sometimes they may give lenses are also moving like this, no, then apply this formula, clear. So this is for perpendicular, no, and this is for along the principal axis, no, clear. Along the principal axis square, so perpendicular to this one is nothing but a square will not be there, that's all. So these things, no, you need to remember, so then you can practice this type of questions, no, so that you can become perfect now. Now let us see here, no, right, here mirror combinations, no, we are going to get it, no. So here what they are asking, no, find out the value of x, we want to calculate this distance, no, such that a light rays retrace its path after reflection from the mirror, no. Okay, so therefore retrace its path means compulsory, what you can get it now, retrace its path means, so compulsory light ray should fall along the center of curvature, no, clear. So definitely from here, so if a light ray is coming and falling at this point, no, compulsory it should retrace, no. So that means compulsory this should be the center of curvature, that means this distance should be compulsory 2f, clear. And this distance is, suppose it is v, now the distance between the x is equals to, therefore v plus 2f, clear. So we want to calculate it, no, we will calculate the v. So therefore here you can use this one, no. So u is equals to minus 30 centimeter, no, focal length is equals to 20 centimeter, 1 by f is equals to 1 by v minus 1 by u. So therefore 1 by 20 is equals to 1 by v minus of minus plus 1 by 30. So 1 by v is equals to 1 by 20 minus 1 by 30. So we can make it to 60, therefore multiply 3, multiply 2. So therefore 3 minus 2, therefore 1 by v is equals to 1 by 60. So v is equals to 60 centimeter. Clear? So plus 60. So therefore here x is equals to, so 60 plus 2 into f. F is how much? No, 10. Therefore 20. Therefore 80 centimeter. Clear? So this should be your distance is x between the lens and the mirror now. Clear? So right. So how the ray diagram will be there now? This ray diagram, it will go like this, therefore it is go like this, it is go like this. Then it is come back in this direction, come back in this direction, come back in this direction. Clear? Like this you need to find it now. Clear? Now we will go for another question now. A point source S is placed at a distance of 15 centimeter from a converging lens of focal length is 10 centimeter on the principal axis. Where should be the diverging mirror of focal length 12 centimeter should be placed so that the real image is formed at the source itself. Diverging mirror, okay. So there is a point source is there. What we will do, we will see therefore here there is a source is there now. This is a source at a distance of 15 from the converging lens. Converging lens means convex lens. Therefore, this is your convex lens. Focal length is how much now? 15 centimeter. Focal length is how much now? 10 centimeter. At what distance is kept now? 15 centimeter it is kept here now. Clear? On the principal axis, where the diverging mirror of focal length 12 centimeters should be placed. Therefore, there is a one diverging mirror should be placed here now. Diverging mirror means what? A convex mirror. Clear? So that means he is asking this distance is x. So what is happening now here? Therefore, here it has to real image placed so that the real image is formed on the source itself. That means here light rays are coming and falling at this point now. Therefore, light rays are coming and falling. So therefore, here what should happen now? Definitely, so this should be fall at the center of curvature. Then only it will be rebound back onto this. Center of curvature now. Therefore, then it is going to retrace its path here now. Clear? So definitely this is going to form at this is going to fall at so this should be compulsory 2f. Clear? You understand? No? Therefore, here 2f. This is your 2f. No? Therefore, this light ray should come and fall onto this one. No? Clear? So that means this is 2f means we want to calculate this is your image distance now. So therefore, our x distance it will be equal to, therefore v minus 2f should be your x distance now. Clear? So here therefore focal length is given already. Focal length of this one is how much now? 12 centimeter now. Clear? Placed at 15 centimeter now. Therefore, this x now, x is equals to, so v minus 2f, right. So, we want to calculate v. So, therefore, here 1 by f is equals to 1 by v minus 1 by u. So, 1 by 10, so it will be equal to 1 by v minus of minus 1 by 15. Therefore, 1 by v is equals to 1 by 10 minus 1 by 15. So, 30, therefore, 3 into 2. So, v is equals to 30 centimeter. 30 centimeter now. Clear? So, therefore, x value should be equal to distance between these two mirrors. No, this should be the 30 minus 2 into therefore 12. Therefore, 30 minus 24, 6 centimeters. They should keep it between these one, no, 6 centimeters, so that therefore final image will be formed at the source itself. Clear? So the combination of the mirrors and the lenses know how to solve these type of problems. So clear? Now let us see one more question. Let us see this question, no? Right? A point object is placed at a distance of 60 centimeter from the convex lens of focal length is 30 centimeter. Okay. If the plane mirror is put perpendicular to the principal axis, no, at a distance of 40 centimeter from it. So he is asking final image where it is going to form, right? So I think most of the students know, therefore they will confuse you. They will confuse in this one, no. So let us see what is that confusion, no. Finally, where is going to form the image. So first let us see this lens, no. Therefore here object is there 1 by f, 1 by 30 is equals to 1 by v. So minus of minus plus 1 by 60. So 1 by v is equals to 1 by 30 minus 1 by 60. So I can multiply 2, therefore 2. So 2 minus 1, 1 by 60. So therefore v is equals to plus 60 centimeter. Clear? So where the image is going to create it now, therefore here the light rays are coming here, no, therefore falling at this point. So then therefore the image is going to formed at a distance of, therefore here, so therefore at 20, okay, this is from here to here 60, from here to here 40, means the compulsory this is about 20 centimeter. Clear? So therefore here it will be the 20 centimeter from the mirror, no, it is going to form. Clear? So how it is there now? It is really, therefore here this is not going to form any real. So therefore this light rays, what will happen now? It is going to rebound back, no, and this light rays will come and form here now. Clear? You understand, no? Therefore this it will be the virtual image, no, therefore 20 centimeter from the plane mirror it would be the virtual. So to the right side, this is will be the answer is there. So most of the students know they will think that here 20 centimeter from the lens it would be the real image. So this also one option is correct is there, but here 40 centimeter, here 20 centimeter, most of the students they will come to and stop here, no, and they will go for this, but really this is not the answer, no. Why it is not the answer? Let us see this one, no. So these light rays, no, will not stop here, it will come back to this, therefore, and therefore there will be some more other image it is going to form at this point. Clear? These light rays again it will come back and it will be falling on this one, no. So this will be act like an object to this one, no, and for this lens again refraction will be takes place now. Now let us see here this object distance, you know, now you can get it as like a light rays are coming here, no, therefore minus 20 centimeter, no. So 1 by f, therefore 1 by f, f is how much now? Again f is equals to 30 centimeter. So 1 by v, so minus of minus plus 1 by 20. Sir, you can take it this side, no? No, light rays are coming here, no? Then we can take it as 1 by v, so therefore 1 by 30 minus 1 by 20. So therefore here I can multiply 3, I can multiply 2 here, no? So minus 1 by 60. So v is equals to minus 60 centimeter, that means opposite to the object. So if you are taking this is here to this one, no, therefore here somewhere it will be going to form it as 60 centimeter from here, no. Clear? Therefore from the lens, no, 60 centimeter, that's why it is wrong answer, right? So this also wrong. So most probable answer is only second one. Clear? So the confusion, mostly the students will come and stop here itself, again further one, no, they are not going to see it. Clear? Understood, no? Right. Now let us go for another question, no? Now let us see here, no, this question. So is asking optical power of this, no, therefore I already told one formula, power is equals to n2 minus n1 by r, n2 after refraction which is entering, this should be the n2 and this should be the n1. Clear? n2 is how much now? 3 by 2 minus 1 divided by radius of curvature. So take this is your origin, no, this side it is positive, so 10 centimeter plus. So how much it will be now? Minus 1 by 2, therefore 1 by 20. So therefore, because minus 1 by 2, 1 by 20, therefore 1 by 20. So therefore diopter will be your power of this, plus it is in the convex in nature. Clear? Plus I got it. Right. Now let us go for here, no, one more question. Right. So find the optical power of the plane surface. What is the optical power now? So plane surface, no, power is equals to n2 3 by 2 minus 1. This is a plane surface, r will be at infinity. Therefore power it will be the 0 for this plane surface. There is no converging, there is no diverging like that, no. Therefore, so therefore power it will be the 0 on this. Clear? Right, students? Okay, so I hope I already covered most of the concepts which is related to the lens, okay, and combination of the lenses, no, right? So in the next video, so we'll go for lens maker formula and application for related to the lenses and different type of lenses, how to calculate the focal lengths and of the combination if the lenses are in contact, and if you cutting of the lens, no, therefore like that questions also, and if the lens is immersed inside the water, so are any liquid, no, what should be the nature of the focal length of this. So these all the things, no, we will discuss. So about the lens maker formula in the next video, right. So thank you for watching. Please subscribe to my channel. So I hope you all are learning the physics through my YouTube video. Thank you.